Thanks for that intro, Corey. Excuse me. I'd first like to thank my co-authors on this paper, Scott Sapper, also of Wisconsin DNR, and Mike Sider of Fish and Wildlife Service out of Ashland. Really excited about this paper regarding protected areas in Lake Whitefish in the Apostle Islands, so I'm just going to get right into it. So in the Great Lakes, we really have a variety of tools to regulate harvest of whitefish. A really common method is directly regulating harvest is using quotas. However, quotas can get pretty tricky at times because they actually require knowing exactly how many fish are out there, which is difficult, and the ability to adjust those quotas on a frequent basis. However, there are also tools that indirectly regulate harvests, including things like effort limits, seasons, and gear restrictions. But one method that isn't really commonly mentioned are aquatic protected areas, and this may be due to the notion that this type of tool is generally saved for conservation purposes or rehab purposes. But in this presentation, it's my goal to convince you APAs should be considered a pretty big tool in this management toolbox. First off, we've had a long history of research evaluating many aspects of lake trout refuges in the Apostle Islands. You can see them pictured on this map. These two refuges are fully protected no-take areas, so no commercial fishing, no sport fishing of any kind. These refuges were designed around historically important lake trout spawning habitat and rearing areas, and they've been very well studied over the past 45 years. Originally, they were created for rehabilitation goals. However, since we've kind of successfully rehabbed lake trout in this region, we've continued to use these refuges as management tools, helping maintain spawning biomass around these really important reefs and prevent over-harvest, kind of give a harvest buffer in an aggressive harvest management strategy. So this is one example of how these aquatic protected areas have morphed from rehabilitation tools to management tools. So what do we know about protected areas in Carignenes, though? Basically nothing. No APAs have ever been created specifically for Carignenes in the Great Lakes, at least none that we're aware of. However, a large review by Hedges et al. Did conclude that diverse APAs do exist out in the Great Lakes. And they also concluded networks of different types of APAs can achieve multiple ecosystem goals. And importantly, APAs don't have to be fully protected refuges. There's a wide spectrum of protection levels available to managers, and this is just a very complex categorization system in marine protected areas in the marine world. However, for this analysis, we're going to be looking into a lot simpler classification, just fully protected or no-take refuges where no extractions are permitted, partially protected areas where extractions are allowed, but with severe limitations to the things like the species you're able to harvest, season restrictions or gear restrictions, and unprotected areas where that just means there's no additional protections given to a particular area that isn't already encompassed in the management jurisdiction. So here's a map of Management Unit WI2, the Apostle Islands region. It really presents a great opportunity for evaluating the effects of different levels of protected areas, and that's because a little over a third of the total area in WI2 is zoned in additional protections. So in total, the offshore no-take refuges make up about 27% of the regional area. Partially protected areas make up about 10% of the regional area. And all of these areas were established by 1982. And there's kind of two important distinctions between these two different types of protected areas. Namely, the one I kind of brought up first was the level of protection. Like I mentioned, the no-take refuges are fully protected with no extractions at all by any fishery. The PPAs are mainly prohibiting commercial harvests, or in some cases, just severely limiting commercial harvests. But the other important distinction is the habitats they encompass. The no-take refuges were designed around the offshore lean lake trout habitats around historically important spawning areas, but the partially protected areas are mainly located in the nearshore, shallow, and productive regions of the area. You can see those partially protected areas in the orange and the no-take refuges in the green. Those will be the colors throughout the presentation. So the overall objective was to compare lake whitefish population demographics among these different areas. We're going to be looking at recruitment defined as to the spawning stock, mortality, growth, and maturity rates. And we did a simple tag recapture study to investigate some spillover dynamics, including recapture distances and exportation rates. So coming back to this map, we have 39 summer survey sampling sites around the unit. This is a fishery independent graded mesh gillnet survey, 9 locations within the fully protected no-take refuges, 8 within the PPAs, and 22 in unprotected areas, or kind of our control sites. The survey has been ongoing from 1980 to 2022 in even years. And so essentially what we have is a 43-year time series of relative abundance indices for each of these 3 different areas. So we evaluated 3 different measures of relative abundance: a juvenile index, a recruited or adult fish index, and a total biomass index. And the way we differentiated between juveniles and recruits is each individual whitefish was assigned a juvenile or an adult recruit classification by our observed length at 50% maturity at specific to each protected area type. And our third measure, again, total biomass kilograms per kilometer. But our next question was, what's an actual representative timeline that's appropriate for evaluating the response of a protected area, specifically for whitefish? So we referenced a study in the marine realm where they evaluated exactly this for several different marine species of varying life histories in MPAs. And they found a relationship between M, natural mortality, and the expected recovery time. Our best guess for M in the Apostle Islands comes from our catch at age monitoring, which Mike's going to be talking about right after me. It's about 0.13, which is going to amount to expected recovery timeline of about 18 years. So we use that 18-year time frame to split the whole time series into a phase 1 and a phase 2, kind of representing an initial rebuild phase and a post-rebuild phase. Linear models we used were log CPUE predicted by a year, the protected area type, and a year area interaction, and we'll be testing for that interaction to test for differences in slope. So first, in the rebuild phase for juvenile whitefish, we had no significant interaction between year and area for any of the models. So essentially, no benefit provided by either type of protected area for juvenile whitefish compared to the control. However, this wasn't exactly surprising, since the mechanism of protected areas is reducing fishing mortality, which primarily occurs on the adults. So in the recruitment index, again, those adults recruited to the spawning stock, we did see a much faster rate of increase in both the offshore refuges and the partially protected areas compared to the unprotected areas, or that control, during the initial period. Similar story in the biomass index, although it's even a little bit more pronounced. Again, faster rate of growth in the PPAs and offshore lake trout refuges compared to the control. So that's what happened in phase 1. What about the post-rebuild? Juvenile index, the index stabilized. There isn't even a year effect, as well as no significant interaction. Same with the recruitment index, no interaction, no year effect. And again, with the biomass index, no interaction, no year effect, a bunch of flat lines and pretty stable stocks and recruitment. So ultimately, all of our indices stabilized in the phase 2 period. But I also want you to notice that in that recruitment index, back in 1980, the first year of the survey, in both the protected area types, those are 0 catches in that first year. And since then, especially in the partially protected areas in those nearshore habitats. Those habitats are encompassing some of the highest densities of whitefish in the entire region. So it's quite the turnaround. Moving on to contemporary total mortality, catch curves indicated that nearshore partially protected area total mortality, or the fish captured in those areas, was lower than both the offshore refuges and the unprotected areas. Growth and size structure, pictured here are the simple Von B growth models for the different areas. Nearshore PPAs had noticeably faster growth rates and growth potential than the other areas. So that combined with lower mortality, adult size structure is much larger in these nearshore productive habitats. And I want to make sure to make the distinction that the reduction of fishing mortality in those partially protected areas likely isn't the cause of greater growth rates. That's why I brought up the difference in habitats that these protected areas encompass. So lastly here, looking at age at maturity, shaded regions here are bootstrapped 95% confidence intervals around the age at 50% maturity. Again, difference between the nearshore partially protected areas and unprotected areas. Almost 2 full years earlier, the fish are maturing in those nearshore regions. So hopefully it's been pretty convincing that these protected areas can be used as rehabilitation tools. But as a fishery manager, I also want to know if these protected areas are actually benefiting the fishery. We did observe quite a few indications of fishery spillover, first looking here at the commercial gillnet catch rates for whitefish in the region. Again, looking on the log scale here. Looks pretty much like the same trend as the fishery independent surveys within the protected areas, just delayed a few years here at the beginning, which is kind of what you'd expect. And here we have mean size of an adult whitefish through time. So mean size is decreasing through time in the 2 different protected areas. Remember, that's also as the densities are increasing. And it kind of matches spillover theory, where we expect it's those density dependent processes that are forcing fish outside of the protected areas and into the fishing grounds. We didn't see that effect in the unprotected areas. We also conducted a simple tag recapture study, tagged fish released from commercial trap nets, got recapture reports from commercial fishers in both trap net and gillnet fisheries. So we tagged a bunch of fish within the nearshore PPA, there in the orange at those dots, and we tagged a bunch of fish near the southern boundary of one of the no-take refuges in the green dots, and those shaded regions are kind of like the smoothed over recapture range that we observed. And pictured on the right are the recapture distance frequencies we observed between the 2 areas, and the fish tagged in the shallow nearshore PPA did tend to move on average shorter distances, seemed a little bit more confined to the shallow region. So we kind of learned 2 things from this study. First off, the boundaries dividing the more contiguous habitats of the offshore refuges may be more porous, and depth may be an important factor influencing that boundary porosity, something that's brought up a lot in the marine protected area realm. We observed an exportation rate of about 13% out of the Van Tassel's PPA, and that kind of just possibly gives some sort of a sense of an idea of the fishery spillover that's occurring. So wrapping it up here, both the offshore refuges and the nearshore PPAs enhanced whitefish recruitment in the Apostle Islands region. We've experienced a relatively stable fishery, stock, and recruitment ever since, as you'll notice from Mike Sider's update that he's going to again present right after. Contemporary total mortality was lower in the nearshore PPAs, and these areas also contain larger, faster growing, and earlier maturing fish, and we have several pieces of evidence that fishery spillover has occurred and help benefit the fishery. But besides just fishery spillover, the network of protected areas has conceivably been a major factor in promoting stable recruitment in the Apostle Islands region, like I just mentioned. There's kind of 2 trains of thought here. First off, we know from this study that networks of protected areas can help preserve diverse population demographics among multiple habitats. And we assume that a stochastic environment creates recruitment asynchrony. So, kind of according to portfolio theory, this should give the entire region better odds of consistent recruitment by protecting spawning fish in a variety of habitats. Second, we know recruitment is also at least partially dependent on spawning biomass. Moulton et al. 2013 recommended to conserve spawning biomass of whitefish to ensure consistent fisheries with consistent recruitment through time. And in this study, we did show that nearshore PPAs in those appropriately productive habitats did act as reservoirs of highly fecund fish, so hopefully helping us achieve that recommendation. So kind of in financial terms, I can kind of think of this as fish the interest, not the principal. Diversifying the assets across multiple habitats, leaving them be, letting them accrue interest, and really just trying to fish that interest. And that leads to an overall more stable fishery, like we've observed in the Apostle Islands. So in conclusion, implementing fully protected refuges is often difficult, if not impossible. However, in our case, the partially protected areas provided an avenue for giving some protection for vulnerable stocks of whitefish, where prohibiting all harvest was not feasible. So we were able to show that these areas provided similar benefits as fully protected areas by just reducing commercial harvest with partial protection. So fishery managers should consider implementing networks of protected areas as management tools in a more holistic management strategy for lake whitefish in the Great Lakes. And that's what I've got for today. Thanks.